Hi guys, hopefully all of you are doing very well. Here, today we will discuss in this video the regression lines. In the regression lines here, we mainly discuss about that how can we find the angle between two regression lines. So here, when we will find the regression lines, the angles between two regression lines, first we have to know that what are the regression lines. Actually, we know that the regression lines always state the regression line stands for the trend line. That means that which one is now the trending in the market. So this is the application of the regression lines. So whatever here in this video we will discuss about that how can we find the angle between two regression lines. So basically we know that there are two types of regression lines, that is y, and we define the regression line as y on x and another one is x on y. So what is y on x? The regression line y on x and x on y, that is the y on x is like the y minus y bar is equal to r sigma y by sigma x into x minus x. This is the regression line of y on x, that is here y is the depend on x and x on y means here the regression line is of the form x minus x bar is equal to r sigma x by sigma y y minus y. And here basically r sigma y by sigma x, here this one is basically denoted as byx, and this one r sigma x by sigma y is known as the bxy, and this byx and b and bxy are known as the regression coefficient, are known as the regression coefficient. So now here, and the product of this regression coefficient gives the correlation coefficient. R is equal to root over byx into bxy, and whatever the sign of R will depend on byx and bxy, and always here byx and bxy are always of same sign, are always of same sign. So now here we have to know that how can we find the angle between these two lines, that is y minus y bar is equal to r sigma y by sigma x into x minus x bar and x minus x on y, that is x minus x bar into r sigma x by sigma y into y minus y bar. So let's see that how can we find. So if we go to the our school coordinate geometry, we know that we can find the angle between two lines like y is equal to m1x plus c1 and y is equal to m2x plus c2. Then the angle between these two lines are defined by the tan theta, or the tangent. This angle is modulus of m1 minus m2 by 1 plus m1 m2, where m1 and m2 are the gradient of the straight line. Here regression lines are also the equation of straight line. So now see here that if we follow this one, that y minus y bar is equal to r sigma y by sigma x into x minus x bar, then we can write it by like this one, r sigma y by sigma x plus y bar minus r sigma y by sigma x into x bar. So see here that this is quite similar to this one, that is here we can say that m1 is equal to r sigma y by sigma x. This is the c1, that is this is a constant part. Similarly from here, that is the x minus x bar, or from here can we write that if we follow this one, that can we write from here that y minus y bar is equal to 1 by r sigma x by sigma y into x minus x bar. So here, and also if we consider it, so now can we write this one, that is this is 1 by r sigma y by sigma x into x minus x bar, and this is also is of the form, this is also is of the form m2x plus c2, that this is quite similar to this one, and here m2 is equal to 1 by r sigma y by sigma. So now we have to just put this value of m2 and this value of m1 into this equation, and then we can find the angle between the two regression lines. So here what we get, that m1 is equal to r sigma y by sigma x and m2 is equal to 1 by r sigma y sigma x. So let's see that how can I find the angle between two regression lines. So now see here, the tan theta is equal to, now we can put that m1 minus m2 by 1 plus m1 m2. So what is the value of m1? We get r sigma y by sigma x, and m2 1 by r sigma y into sigma x. That is, this one is r sigma y by sigma x minus 1 by r sigma y by sigma x divided by 1 plus r into sigma y by sigma x into 1 by r sigma y by sigma x. So from here, can we write this one by like this? That from here we can write r minus 1 by r sigma y by sigma x. Here these r and these r will be cancelled out. So we get from here 1 plus sigma y square by sigma x square. And now see here that this is under the modulus. So from here can we find this one like 1 minus r square by r into, that is sigma x into sigma y by sigma x square plus sigma y square. If we simplify, we will get this one. That is 1 minus r square by r sigma x into sigma y by sigma x square plus sigma y square. So now see that from here, we can say that if r is equal to 1, then, and here this r is the correlation coefficient, and this is always lying between minus 1 r to minus 1 to plus 1. So when r is equal to 1, we can easily say that theta is equal to 0, and when r is equal to 0, theta is equal to pi by 2. That means here the regression lines are parallel to each other, This is the sign of parallel, and for here, for theta is equal to pi by 2, this is infinity. Sorry, for r is equal to 0, theta is equal to pi by 2. So here the regression lines are perpendicular to each other. This is the sign of perpendicular to each other. So this is the formula that how can we find that tan theta between the tangent between the two regression lines is 1 minus r square divided by r into sigma x sigma y by sigma x square plus sigma y square. So now here we get the angle between these two lines. So now if we want to solve some problems regarding the angle between two regression lines. So let's see that how can we find the angle between two regression lines by some examples. So see here, this one is the very first question I have just given, that if byx is equal to 0.8 and bxy is equal to 0.4. Okay, so now here we know that the regression line of y on x, this one, and regression line of x on y is r sigma x by sigma y, I minus y. So from here, how can I find the angle between this line? And we know that the tan theta is equal to 1 minus r square by r sigma x into sigma y by sigma x square plus sigma y square. And we know that this one is known as the byx and this one is known as the bxy. Here this is given and here we know this relation. So how can we find the angle? So let's see that how can we find the angle by modifying this formula. So let's see that from here we just make it 1 minus r square into divided by r. So now can we write this one by sigma x into sigma y. So now from here can we write this one sigma x by sigma y plus sigma y by sigma x. So now see from here we can write 1 minus r square into 1 divided by r sigma x by sigma y plus r sigma y by sigma x. And we know that this one is equal to byx and this is bxy, and also we know that r square is equal to byx into bxy. So now from here can we write, I just write it here, that is 1 minus bxy into byx divided by byx plus bxy. See, r sigma x by sigma y is equal to, we know that this is bxy and r sigma y by sigma is byx, and we know that r square is equal to byx into bxy. So now can we write here the angle between two regression lines tan theta is equal to 1 minus bxy divided by byx plus bxy. So now if we just simplify, so how can we find the angles now? That is, here just we put the values of bxy. That is 1 minus 0 0.8 into 0 0.4 divided by 0 0.8 plus 0 0.4. So now just put the values and here I just calculate. I just calculate and then I will get the value, and the value will be 0 0.56 and whatever you will get. So now if you find here, so now I can find the value of the angle. So this is, so now you can complete it. So now I am going to the next. And if you simplify, I just give you the simplified results here. That is 0 0.8 plus 0 0.4, 1.2. So you will get here, this is 0 0.56. 0 0.56. So now I'm going to the next one. That is, here this one is another one question that we have to find the angle between the regression lines of 6x plus 15y is equal to 27 and 6x plus 3y is equal to 15. So let's check that how can I find the angle between regression lines of given these two regression lines. See here that here this is not given that which one is y on x and which one is x on y. So here we will assume that which one is x on y and which one is y on x. So here we assume that the x on y is 6x plus 15y is equal to 27, and we take y on x is 6x plus 3y is equal to 15. So x on y means we can write this one, x is equal 6x is equal to 27 minus 15y. So from here we can write that x is equal to 27 by 6 minus 15 by 6y, and so from here we can say that this one is minus 5 by 2y plus 9 by 2. So this is the regression line of x and y, and y on x, that is 6x plus 3 is equal to 15. So here we can write 3y is equal to minus 6x plus 15, or y is equal to minus 2x plus 5. So here this is the regression lines, that is y is equal to minus 2x plus 5, and y is equal to x is equal to minus 5 by 2y plus 9 by 2. So from here you can see that if we consider the equation like x is equal to minus 5 by 2y plus 9 by 2, and y is equal to minus 2x plus 5. So see here that this is the regression line of x on y, and this is y on x. And see here that here the coefficient, that is the bxy, is minus 5 by 2, and byx is minus 2. So here see that both the bxy and byx are same sign. So you can say that our assumption is correct. This is the x on y, the regression line is 6x plus 15 is equal to 27, and the y on x is 6x plus 3y is equal to 15. So now here we have to find the angle, so and we know that tan theta is equal to 1 minus r square, that is 1 minus byx into bxy by byx plus bx. So here just put the values here, then we will get the angles. That is here we have to take the modulus sign. So here already we get the, always we get here the positive sign, that is 1 is a minus 5 by 2 into 2, that is this one is minus 5 by m1 plus m2, here this is the minus, so we get 5 by 2 plus 2, and so from here what do we get, that is 4 divided by 2 to the 4, that is 9 by 2. So from here we will get the angle is tan theta is equal to 8 by 9. So I hope you will find the answer from here, that is tan theta is equal to 8 by 9. So now from here, so and here one thing, I think there's a question you find that here if we take x on y as 6x plus 3y is equal to 15, and y on x is 6x plus 15 is equal to 27, that means the vice versa, then what will you do? Actually in that case you will find that rxy is negative, the opposite of sign, then you can say your assumption is wrong, so then you just write the vice versa, no need to write anything else. Okay, and here now I'm going to the next one. Okay, this question, that if sigma y is equal to 2 sigma x, then find the tangent between the two regression lines where r is equal to 0.25. That means here we have to find again the regression lines, that is tan theta is equal to, here sigma y is equal to 2 sigma, this is given. So this is 1 minus r squared by r See, here we will use this one. And see, it is given that sigma y is equal to sigma x and the value of r is also given. So just now simplifying this one. Sigma x into 2 sigma x divided by sigma x square plus 4 sigma x square 1 minus 0.25 whole square by 0.25 into 2 sigma x square by 5 sigma x square, and if you simplify here now we will get from here 3.75 into 2 by 5. So here we will get a value that is 1.4. This is the value of tangent. So I hope you understand that how can you find the angle between two regression lines. And here there is another one question from here, that if r is equal to 0.5 and angle between the two regression line is tan inverse 3 by 5, then show that sigma x is equal to 0.5 sigma y. That means here also we have to use the form, that is tan theta is equal to 1 minus r squared by r sigma x sigma y by sigma x square plus sigma y square, and it is the, and from here we can write that theta is equal to tan inverse 1 minus r square by r sigma x sigma y by sigma x square plus sigma y square. And so it is given that this tan inverse 3 by 5, so I can write tan inverse 3 by 5 is equal to tan inverse 1 minus r square by r into sigma x sigma y by sigma x square plus sigma y square. And so from here can we write 3 by 5 is equal to 1 minus 0.5 whole square by 0.5 into sigma x sigma y by sigma x square plus sigma y square. So now we have to just simplify this one. That is, if we simplify, so here we will get 1.5, that means 3 by 2, 3 by 5 sigma x sigma y by sigma x square plus sigma y square. So now this 3 and this 3 will be cancelled out, and from here we can write 2 sigma x square plus 2 sigma y square is equal to 5 sigma x sigma y. Or from here also we can write this one, and now from here we can write this one. Okay, so now from here if we simplify from here, we can adjust 2 sigma x common, sigma x minus 2 sigma y, and if we common from here the sigma y, that is minus sigma y, that is sigma x minus 2 sigma y is equal to 0. And so now from here we can write that sigma x minus 2 sigma y into 2 sigma x minus sigma y is equal to 0. So from here we will get two results, that either sigma x is equal to 2 sigma y or 2 sigma x is equal to sigma y, and here we have to show that this one, so we can say that this one is not equal to 0, so then we just take this result and then we can write sigma x is equal to half sigma y, this is 0.5 sigma. So I hope you understand that how can you find the angle between two regression lines and how to solve different type of problems regarding this topic. So thank you for watching the video.